here, and then we'll see what we can do on that one. Let me get, I see if my pointer works here. Okay, there you go. All right, basic motor control. We talked about motors, guys. I have a controller right here for you. We talked about this one before in the commercial project. We will continue to talk about it in the industrial project because you're so important. When you go work in a place, the first thing you guys want to do is you want to circuit your equipment, and then the second thing will be how are we going to control these equipments? Matt, do you remember the mechanical schedule that you guys did for the commercial project? It's motor control, how you're going to control it, and so forth. So that's what this chapter is so important, guys. We're not electricians, so you're not going to be installing it, but you need to understand a lot how the system works, what type of control you can do with motors. Okay, basic motor control. A few things, guys, I would like to. The worst thing that could happen to you guys as a designer, Karen, to walk into a building and you really have no idea what tool. I know you guys did it with the electrician program. What type of controls we have for these machines, air handling units, chillers, and what's not. So at least you need to understand them. Obviously, control is a whole different topic, Matt. People have Bachelor of Science in control. I mean, point-to-point control and wiring and so forth. We need to know enough so we can specify the system. And Derek, if you are to work as an estimator, to take off that system and understand it, right? That's all what we're required to do. Okay, difference between contactor and starter. You're going to hear this terminology as motor starter and contactor all the time. I hope we talked about these before. Contactor is nothing other than a switch, open and close by energizing a coil. A motor starter, you're looking at a motor starter right here, guys. Have a contactor right here and an overload. It has a contactor and an overload. That's it. So if you put a contactor that open and close and an overload, if you add an overload plus the contactor, that will get you the starter for the motors. Then we'll talk about, guys, fuse protection as well as overload protection. We talked about the difference between the function of the fuse and the function of the overload. Fuse will protect you from short circuit, and overload will protect you from overload. Matt, does that sound familiar to you now? How many times we hit it now? 3 times. After that, we'll hit you out the door, right? After that. Okay, list different types of overload relays. So different types of overload that we use with these systems. Typically, we don't get involved too much in specifying the overloads. It comes with the starters. Almost all of them right now, for the most part, guys, you're looking at electronic overloads. So, but it's really nice to know what they are and how they operate. What do they do for a living? So these are what this chapter, guys, talks about. There's also control circuits. Basic control circuit. Control circuit, like I said, guys, I'm an engineer, master electrician, and I still get confused between control circuit. There's a whole lot when it comes to interfacing with PLCs and everything else. Derek, it's a complete different topic. And if you are an electrical designer who branch into the control circuit and start doing control, it's really, you can make good money. So keep in mind, when you work, you might work for a company that they put you, instead of laying out design, laying out point-to-point schematics. I have students went to do schematics. That's what the schematics, instead of doing circuiting, they do point-to-point. Take this point from this contactor to this contactor to this relay. That's also design. So be aware of that one. So basic control circuit using so-called schematic diagrams. Difference between schematics and wiring diagram. You guys, we focus a lot on the wiring diagram here. The schematic diagrams, guys, will show you how the system is going to operate. The way I describe it, Karen, the wiring diagram that we power these equipment, it's like the frame. Imagine us. Your frame is the wiring diagram, but without the brain, your frame is worthless, right? And we'll also, without the brain, your frame, your body is worthless, and without your body, your brain is worthless. Can you have a brain functioning by itself or a body functioning without a brain? So control and wiring, guys, are powering the equipment and controlling it, Adam, exactly like having a brain for the equipment. So I can't emphasize this enough. We have the schematic diagrams or the ladder diagrams and the wiring diagrams. We'll talk about the differences. We focus a lot on the wiring diagrams. The schematic diagrams is mostly on the control side. When it comes to wiring, guys, there's a term that they use, and this is not new to you. It's called two-wire control. Two-wire control, here you're looking at two-wire control right here. You see that control turn on and off the light? That's a two-wire control. You interrupt the circuit that going to the motor, and when you interrupt it, you have to physically, mechanically go there to turn it on. Two-wire control. Another two-wire control, guys, is the thermostat in your house and your furnace. That's a two-wire control, right? So when it calls for heat, the heater comes on, heat the house. When the temperature reaches the desired 75 for my wife, 68 for me, it drops down to the then it will turn it off. But you don't go turn it off you yourself manually. So that's your so it disconnects the power to the motor. That's the wire. You'll look at it in a second. Overload protection is provided for motors. You have to provide the motor for being overloaded. The overload protector from overloading. It's not a circuit breaker protection, guys. It protects the overload, protect you from overloading the motor. If it can handle 50 horsepower, don't put 55 on it. That's it. Short circuit, don't bring phase A to phase B and flip the time together, flip the switch. That's your short circuit. There are manual starters. They use them slightly with manual starters. And inside these manual starters, they have an overload. I know Adam and Kieran, I'm not sure, and you and Derek, you guys did them with Scott, do you remember? Or you did it with Scott, you guys did them in the motor lab, and you wired these three-phase or single-phase manual starter with an overload in them. They look like a switch like this, and you wire them. Matt, you will be wiring the next quarter. When you go there, you'll hear, this is a review for you next semester. When you leave here, you're going to go, they talk about manual three-phase or single-phase starter, grab them and go wire. The rest of you guys, you should have wired them. Overload protection, you have to have an overload with them. Okay, gentlemen, here's your, what's it called, the single-phase control. Here's a single line diagram. You have a switch, you turn this switch on, you bring, there's your circuit breaker, this is your overtransmission device. There's your controller here. You turn this motor on and off with a switch like this. Schematics for it, it looks like this. That's schematics, obviously. That's called manual. Can you guys see the word manual? Nobody, you have to go physically, mechanically push the button to start it and stop it. That's your manual. Now also you have a manual for single phase. They have a manual that looks like this. So these contacts, guys, you have to interfere in order to turn these contacts on and off. I want to bring to your attention, guys, to the symbol that they use for the overload. Overload, if that air handling unit is overloaded, it will trip and open this contact, open the contacts to de-energize the motor. That contactor is manually operated. That's schematic diagram for manual start. I can't emphasize the word manual. So these contacts here, they're not driven by a coil. They're driven by push, by your foot or your finger or your hand. Manual starters, this is review probably for you too, Matt. When you go to our second quarter with Jeff will say, grab a manual starter three-phase. You're going to go grab that manual starter three-phase and bring it. These contacts, guys, they are not driven by a coil. These contacts are driven by a physical mechanical movement. And these are the overload heaters, typically with it, or coils, your heaters, to protect you from overload. Three-phase, phase A, phase B, phase C. Okay, so that's your so-called, they call it contact, two-wire contact. So basically, your two-wire contact, guys, require you to manual intervention. Manual intervention if it's manual. If it's auto, like your thermostat, it will turn it on and off at the same time. Whenever it's needed without intervention. So there's manual and there's auto. There's a three-wire connection. With the three-wire connection, guys, they use this one. They use start-stop buttons. You're looking at them with a magnetic contactor. So you start introducing something called a magnetic contactor. Magnetic contactor is a fancy name for a coil and a multiple contacts that this coil is going to drive. So you bring 120 volt across this coil, and this, when you energize it with 120 direct, what happens is these will close. That's what magnetic contactor is. You have to have a coil. This one, guys, is not a magnetic contactor. These contactors are driven and closed manually. They look like a magnetic contactor. I can make this a magnetic contactor by putting a coil here and 120 and making this coil drive these contacts. Now it's a magnetic contactor. So that's your magnetic contactor. it has a solenoid, which is your coil, that closes a set of contacts to energize them and open them to the energizer. Motor starters, they had a contactor, number one, that was on the test, and an overload. Two. So, Adam, when anybody tells you, what's the difference between a motor starter and a contactor? Well, a contactor is part of the motor starter plus an overload. That's all. You're looking at it right here, gentlemen. You're looking at contactor here, overload right here. This is what you're going to be wiring that when you go to the second floor. Combination starter. This is a combination starter, guys. You're looking at it. If you look right here in front of you, you have a fuse disconnect right in here. That's your fuse disconnect. You are having a circuit breaker. The circuit breaker right in here. This is non-fuse disconnect. This is circuit breaker. A disconnect tends to isolate the circuit so you can work on it safely. Disconnect it, lock it, tag it, go work on it safely. The circuit breaker to protect you from short circuit and ground fault. Then you have the control transformer. I don't know if we have a control transformer in that one. This is using the same voltage. We don't need a lower voltage. If any, motor starter. Here's my motor starter, guys, right in here. A contactor plus an overload. This is called combo. Why so important, Karen? When you guys start laying out your mechanical schedule, please, you're going to hear them talk about a combo starter. That's what your combo starter. A disconnect, either fused or non-fused. This one is non-fused disconnect. You have to have a circuit breaker if it's non-fused, as well as an overload and a contactor, all in one big enclosure, in one big fat fluffy enclosure. Any comments, guys? Any questions about that? Comments, questions? So very, very important, guys, to do that one. Solenoid or relay, guys, the relay or the solenoid, you should probably understand that one. Here's what the smarter than Chad, what they do is they bring the coil right here. They bring a voltage, say 120 here volt, or you can bring a 240 volt here, voltage source, right? A circuit, like a circuit, you circuit it. And then from this side, guys, they can use, they can wire normally open. So let's just go wire normally open here. And I'm going to grab wire, how am I going to do that? Right in here, can you guys see that? Here's my phase A, hot one. Here's my neutral, and this is going to my motor. Look how easy that is. Now, Adam, every time you put 120 across this coil, you energize this coil, this will move from here to here. Can you guys see that? And then the power from a different circuit will come from here, goes right through that equipment. I'm probably using it the wrong way, all the way into the motor and burning your motor. Any comments, guys? Any questions? Using, every time you see the NO, normally open contacts, and C, normally closed contacts. C is the comment between the both of them. I know you guys don't do a whole lot of wiring, but if you are, when you graduate from here, if there's a job that says we need you guys to do schematics, do you know how to do schematics? What's your answer? Yes, we know how to do schematics. Are you expert in schematics? No. Does that make sense? That's what you're looking at, schematics, knowing how the system works. Okay, schematic symbols. There's so many symbols for schematic. I want to show you some of them, guys. Switch, contact. There's a switch and contact symbols drawn to indicate off position. You'll see them in a second. Limit switches. We'll look at the limit switches, how they draw them. Normally open contact switches, relays and contactors and solenoid drawn as a circle. And you are looking at them right here. So here's the symbols that they use, guys, for when you do schematics. It's all about symbols, control. What you guys are doing with me, what you have been doing for 3 semesters right now, we are powering the equipment, right? And at the end, we say, here's a controller to control these equipment. The schematics is, the focus is the control. How are you going to find 15 machines, guys, involved in making a truck, right? Building a truck, talk to each other via the PLCs and so forth. Okay. This is called normally float switch, guys. Float switch. This is for tanks. If you want to turn on and off a pump until the tank is full, right? You can use a switch like this. Normally open, normally closed. This is a flow switch. They put this switch, guys, in a pipe. Remember do you guys remember tamper switches and flow switches that we did for the fire alarm system, exactly like this. So if the water is to come here and hit this mechanical, this will push it to close, and now you have a 120 here that's going to energize something coming from here, and here's a motor. Now my motor starts. So you bring all your wiring out of here. You bring all your wiring. Here's my normally close, normally open. I have pressure switch driven by pressure. Temperature, these are all pilot devices. Temperature switch driven by temperature, thermostat, normally open, normally close. All these, Adam, their interface in your control circuit. Their interface into your control circuit. Any comments, gentlemen? Any questions? You're going to see a couple of schematics in a second here. Look at all these symbols that you can use, guys, for the control. All these devices, from digital control, common control, electrical schematics. All the symbols right here are very, very common, guys. You can use them all the time. Flow switch, temper switch, proximity switches, and what's not. If you and I are doing control, these are going to be the building blocks of your system. With Revit, guys, we do power, right? Did we worry about these contacts when we were doing Revit? We were dropping major system, electrical power and light, into our system. Okay, there's a lot of conversion, guys, when you're doing VFDs. This becomes very handy, this section here, converting the AC to DC, power conversion. So there's a few digital, if you're building your PLCs, these are all the digital component that you have to build in order to get you your digital output. Okay, so that's a few things, guys, about the control. Overload relays, Karen, protect the motor from being overloaded. The most important thing about overload, moving into overload, after the control, is to protect the motor from being overloaded by disconnecting the power to the motor starter coil, de-energizing the starter coil. There's three ways of doing it, Adam. There is a magnetic. They have a coil, basically, and when that coil picks up some voltage, it will trip. Open a contactor trip. There is electronic, number three. Number two is electronic, number one. Number two is electronic. You have a wire and you have a solenoid, and you're pulling the current, connecting, sensing the current. If the current increases up to 25%, that's an overload, a trip. And the last one, guys, is thermal. What they have a heater, and the current goes through this heater. When this heater heats, it heats a material that melts, and physically, mechanically, when it melts, there is a contact that opens because of that melting process. These are the three types. Typically, for all the engineered projects that we do, they're shooting for electronic. They're more electronic circuit breaker. They're more adjustable, better performance. So what we're talking about right here. This guy had heaters. They have things that melts right inside there. But the new stuff that we specify for all the equipment is electronic overload. Okay, here's the current coil. This is how it looks like, guys. When the current goes up here, so if it's supposed to be 10 amps, this is a 10 amp motor, and now we're pulling, say, 25 amps. Now this guy will pick up. When this guy will pick up, it will open these contacts, right? If one of them will pick up, open this contact. When you open this contact, you de-energize this coil, and up it goes. This coil will open these amp contacts. Any comments, guys? Any questions? Everybody knows how this system works, guys. When you go push the button right in here, you energize this coil. This will close. These contacts, bam, 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 will close. Now my motor is running, right? You guys wire these in the left. The voltage here could be 480, and this side, it transfers down to 120 volt. 120 volt. If Derek went and opened this contact, the stop, this is my stop. If you open the stop, it will de-energize the coil, which de-energizes the motor. That's my overload. The current sensing, the electronic overload looks like this, guys, where if the current here is, say, 100, the motor is supposed to be 100 amp, and we're pulling 150 amp out of it, this will say, I'm just going to say it will pick 3.5 amps, and that will get into this solid state and go open these contacts. So electronically open certain contacts. So any comments, guys? It sense the current electronically, and it activates a contact to open the contact. Any comments, any questions? So that's your electronic relay. The heaters are similar to this, guys. The heaters are very similar to this. Instead of sensing current, they sense heat though. Karen, Adam, any comments, guys? Any questions about these? I can't emphasize, guys. I know you're laying out a lot of stuff, but this is so important to understand. So, overload relays. So three-phase, we have for three-phase motor, guys, single-phase overload relays, we have 3 auxiliary overload contacts in series. You'll just look at them. Three-phase overload relays, 3 separate heaters. We have 3 separate heaters and only 1 set of overload contacts. So if you have heaters, they have 1 set. If you have relays, if you have a relay, guys, we'll have 3 contacts. Here's what we're talking about, guys. Look at this. I have my overload relay. I have a relay here, electronic relay. So they sense, can you guys see there's 3 of them? And each one of them is driving a contact. Can you guys see that? A contact. These are driven by these 3 overloads. Karen, this is your electronic. If you have a heater, can you guys see these 3? All of these 3 are driving the same contact to open. Who cares? So this one that you're looking at right here, guys, is actually heaters, and it's made out of this way. The overload, that's how they open the overload. So if the motor, like I said, it's 100 amp, and you're pulling out of each one of these, or one of them, say 129 amps, it will sense that it will heat, create a heat. The heat will melt certain material. This certain material, when it melts, depending on the design, it will push 2 contacts open. Don't you guys get amazed on these systems? I get amazed how people thought about these. It's unreal. You know, you look at the contactor like this and turning on and off your air handling unit. So that's called your 3-wire. This is so-called the 3-wire control, guys. Here's your wire 1, your wire 2, and here's your wire 3. 3-wire control system versus 2-wire. Schematic and wiring diagrams. The schematics, guys, the difference between schematics shows component in their electrical sequence, how they operate with each other's regard, with no regard, this is the point, no regard to the physical location. We don't care where they're located. We're just going to show how the system is connected. So they will see a contact, guys, that's sitting here, and you have no idea that the contact actually in a completely different room. The wiring diagram, it will show you where the physical location of these components. It will show pictorial representation of the component with connecting wiring. It will show you where this contactor is residing. Is it residing in the push button, or is it residing in the magnetic contactor? Okay, so that's, you're looking, guys, here's your schematics, looking at the top. Can you guys see the schematics here? And down here, you have your wiring diagram. Look at the component that you're wiring. I have my transformer, I have my push button, I have my motor, I have my starter, my magnetic starter right in here, and my source. Can you guys see these are, Karen, can you guys see that these, 1, 2, 3, 4, 5, these 5 things are different separate things, and they're all interconnected compared to the schematics, which really doesn't care much. It's showing them all in their sequential operation, how they are interfaced with each other. When you read schematics, Adam, and you guys did, Karen, Adam, and Matt, Derek, did you do PLCs? Okay, so when you're doing, it's like reading PLCs. You guys did that one, so it's nothing new, yeah? So when you do schematic diagrams, I emphasize that when you read them like reading English, not Arabic, right? You read from left to right. So schematics should be like reading a book. They should, from top to bottom and from left to right. When you say reading a book to some of the people who read from right to left, well, how do you read a book? Right to left or left to right, right? Talk about goofy. Have you ever read a book from right to left? How about, do the Chinese read from top to bottom, or do like this way, top to bottom, right to left? Don't they go this way as they read? That's weird too. So you're going this way, or you're going this way when you read a book. I don't know. I know I used to go this way, from here to that way. So anyway, left, when you read it, you go from, where am I? So we go left to right and top to bottom when you read the schematics. Contacts contain the same, if the contact guys have the same letters, then they're as the coil, then they're driven by that coil. When I start doing control, guys, I so got confused when I was young. Why this coil have C on it or M on it, and this contact has M on it? If they have the same letter, they're driven by the same. One of them is driving the other. One of them is driving the other. When you bring a circuit or a power to a coil, then and you energize it, then the contacts will change positions. The one that were open will close, and the one that were closed will open. So here's a contact, two contacts. These are under normal condition, guys. Normal condition. When you energize the coil here, meaning you put a voltage here, they change position. This becomes closed, and this will open. When you show them in your diagram, you show them under de-energized condition, this way. This is a normally open contact. When you energize, closes. This is a normally closed contact. When you energize the coil, opens. It will help you a lot when you do schematics with us in the third quarter. Okay, here's my contacts, guys. Start some push button here. We have an auxiliary holding contact. This is what we call this is a holding circuit. We talked about this one before, guys. You push the button right here. I want to bring to your attention, guys. Can you see the M here and the M here? This coil is driving these contacts. Done. So when you push this button here, guys, you energize the coil. Now the coil is hot, 120. It's solenoid. It pushes. When a coil pushes, guys, there's a mechanism that pushes contacts physically, mechanically. Then closes its contact, and then bam, bam, bam. This air handling unit is running now by a push of a button. When Adam comes and gets mad and he wants to open this stop button, you push the stop button. Now this is de-energized. Now this will open, and each one of these will open. The equipment will stop functioning. That's, we test these for German master guys in Minnesota. If you don't know this diagram and how to read it, you basically don't know control. You know, when you guys do it with me on Revit, what you did, Adam, is this motor. This is air handling. Here is air handling unit -1. Remember that one? And you tagged it with I'm going to say we're going to tag this one. Here's my circuit coming to it, and we said it's going to be circuit number 5 to it, right? All what you're describing here is just this. This is circuit number 5 that's coming to this equipment. All this junk, Revit wouldn't mess with it. You guys see the difference? This is control. All what we did when you layer off these equipment, air handling unit, we just assign a circuit for it. We just talked about the power to the equipment. All this junk here, that's a control. That's a controller that you did for the schedule, mechanical schedule. When you fill the mechanical schedule, you're describing your mechanical schedule will be describing what type of a controller are you using for these equipments. Okay, so there's also forward reverse motors, guys. Motors carrying are so important because they can move air, move oil, move water, move what else? Cut things, right? But they also sometimes we need to move the air in or out. What do? You move the air out of the room or move it into the room. What do you need? You need to reverse the motor. So there's reverse and forward. In order to reverse and forward, you need 2 starter leads. You have 2 starters. We'll see in a second. They also have interlocking, guys. You do interlocking for them, so you can't start and reverse the motor at the same time and have face-to-face short circuit. Normally a closed reverse contact. So there's mechanical and electrical interlocking. This is how it looks like, Adam. There's 2 contactors. One contactor, magnetic contactor that takes you forward, one reverse. Here's the mechanism. When you push the forward right here to go forward, it will open the reverse. And at the same time, now it closes this one, and the motor bam, bam, bam is going forward, right? And at the same time, it opens this contact, guys, to prevent the motor to prevent you from closing the the reverse button and having line to line short. When we reverse a three-phase motor, Karen, we always switch two phases, phase 1 and 3. Flip them. That's what reversing three-phase motor is. Okay, so you can see there's two contactors. The F drives the F, the R, coil drives the R. The overload, guys, is here. This will drive, these all overloaded driving this contact. Any comments, guys, any questions? Stopping the motor, you need the button to be right here so you can stop the motor regardless of if the motor is going forward or reverse. I don't know if this one here has no, it doesn't have a bypass of working here. Any comments, guys, about reversing a three-phase motor? In your mechanical schedule, Karen, you were scheduling forward and reverse contactor. Most of the equipment forward, but there is function. There is a situation where we need to run the equipment reverse too. Reverse the equipment. The last thing that we have, guys, here is HVAC equipment, central cooling equipment. If you get into the chillers, and if you're getting into doing the chillers and what's not, you have something similar. This is single phase, something like this. So here's your condenser fan. We talked about the condenser fan and the compressor, guys. So they have when you ask for temperature, when the temperature asks for, it energizes. And you can see this FR, which is the fan relay, will close this. Now my compressor fan is running. Then when the flow switch senses there is flow here, it closes this contact, which energizes coil, which closes these contacts. Now my compressor is running. And in order not to create a bomb, guys, by too much pressure here, they have a low pressure and a high pressure safety switches that control the system. And of course, they have an overload for each one of these machines. All this junk, Karen, that you're looking at will be inside your air handling unit, inside your chiller. Remember when we moved to the chiller, we had the VFDs, guys, and what's not around it. That's what they're doing. They have, when you do the control, guys, you need to start and stop the motor, reverse the motor, speed it up, speed it down, safely. Can I emphasize the word safely? So these devices here, right here, is coming because of safety. Because you don't want to have too much pressure in a container and then it will explode and hurt somebody, or too little pressure which you will be sucked in. So control the equipment by starting them, stopping them, reversing them, ramming them, up, down, speed control them, as well as doing this safely. So that's basically what this chapter is about. Derek, this will take you, anything about the control will take you to the next level. So if you work for Mishad, and now a whole lot, but if you end up working for an electrical contractor or machinist or what's not, where they do the point-to-point control, you can make a lot of money just doing control. It really is. You guys are capable of doing CAD. This is all drawn in CAD. All this stuff is drawn in CAD. You are capable of doing control. You are capable of doing control. Okay, so that's acceleration, deceleration, and so forth. Let me see if we missed any of the pictures. That I like to always emphasize a few pictures, my friends. Okay, we talked about the diagrams. Here's the coil, the symbol for the coil. The most important, anybody speak a different language? Derek, do you speak German or Spanish or something? A little bit. The single most important, control is like speaking a language. The single most important language when you speak a language, guys, is understanding the letters. Can you speak English or read English if you don't know the alphabets? What you're looking at right here is the alphabets of control. If you don't know the alphabets of control, good luck understanding control. So in the alphabets of control, a symbol like this in the US means a relay. And we know what a relay is. It's a coil, you energize it, drives a couple of contacts. So you got to understand the alphabets. All these, for example, diode, SCR. Tomorrow I'm going to be talking about the SCR, conversion to DC, normally open, normally closed, resistor. All these guys are alphabets of control. Here's your motor, guys. A couple of motors. The motors have a shaft. That's probably the most important thing is here because you capture torque. and you energize a coil, induce voltage into the rotor, and create a rotating magnetic field that drives this coil, this rotor to move. Of course, you have to facilitate mechanical movement by having bearing here. Stator winding is what you energize, and here's all your connection right here to get your motor. This is, you're looking here at 30 to 40% of every electrical power system in any building. That's the heart of it, the chiller, the pumps, and all this good stuff. Rotating magnetic field, we talked about these one, guys. We talked about the coils and the connections. Here's your coil energizer, control circuit, and I am looking, I bet you, I'm looking at a different one. I'm sorry. I don't want to do that one. This is tomorrow. Ouch. Okay, here's the connection. We'll talk about tomorrow also. We'll talk about these guys. We'll continue to talk about control. Manual, we talked about the manual control, the relay, how the relay works. I thought it looks like tomorrow. Here's your coil, guys, and here's the contacts, movable contacts. That's how physically it looks like. Normally open, normally closed contacts, and the definition, what moves. Here's the moving part and the stationary part and what's not. All the alphabets of control, these are limit switches. A limit switch is you keep moving that, like imagine a gate. Keep moving until it hits something. That's called limit switches. That thing closes a contact, stop the motor. Limit switches. Matt, you will be wearing all these next semester, like I said. Limit switches, different type of limit switches. Okay, here's your flow switches. We talked about these alphabets and the flow switches too. Normally open contacts, normally closed contacts under the energization. This is the normally open push button, the stop and the start. Can you guys see how they draw them? It's so important the way they draw them. These are alphabets. You can't just, can you write the letter A in any shape or form you want it in English? Can you like create another shape for the letter A? You can, that becomes your own language. If you want a language that everybody understands, that's why if you were to draw that symbol this way, every control person should understand that this is this one will be your stop button that we use for a stop button. Okay, so anyway, so all these contacts, double contacts, guys, and what's not, all the symbols that we use, I showed you all this too. The heaters and how they're driving all these motors. Solenoid electronic, we talked about this one. This is how the heaters will heat, guys, and melt, heating, winding, and they call it solder pot. How they work, the mechanical. Bimetallic strip too. I believe that's it. Here's the mechanism, how the thermal heat will affect this one when it melts, guys. It moves up, so these contacts right here and here will open. So the mechanical of working them, different contacts inside them. Relays, driving contacts, different contacts coming out of a relay. So that's all, guys, the contacts, overload and what's not, different type and shapes. So that's what I want to show you. Here's a couple of how it works, guys. It's right here. If you go push the button, can you guys see how you energize the coil? These will close. Now my motor is running. Adam goes push this button. Now my motor is open. Forward and reverse a motor. Here's your forwarding motor. You're reversing a motor. Can you guys see that? Forwarding a motor by closing that forward circuit. Reversing the motor. Do you see the difference when which one you push as you move through it? So this is how they're wired. And the last thing we talked about, guys, is the HVAC equipment and the control that comes with it. Here's a manual magnetic starter. All these. Here's your manual starter. Here's your magnetic starter with the overload at the bottom. Here's the starter here, the NEMAs, overload at the bottom. Combo, you're looking at it right here in the front of you. So different type of control, overloads. So that's basically what this chapter is all about. Any comments, my friends? Any questions? Comments, questions? All these math are so important, guys. I know you probably overwhelmed, like I would do when I was in your age. You know, Chad, we just went from visual calculation into this and that. Guys, if you like this career, you're going to stick with it for a long time. I hope you guys are here for a long time. at least you're introduced to it. And my expectation is not that you're going to be expert in it. You know it. You might branch into this and become a control engineer. Does that make sense? So if you're not overwhelmed, you don't know what we're doing. I really do. If you're overwhelmed, welcome to the club. There's a lot of stuff. At one time, Derek, you're going to specialize, and I'm going to be an estimator. I care less about the details of control. I know enough to do my estimating, and I'm going to move on. Does that make sense? Because it's so much. I mean, they're control engineers, guys. They live this inside out. But you need to know enough to understand it, though. You're in the electrical industry. Nobody can talk about magnetic starter and you say, what's a magnetic starter? I mean, we're in trouble. Does that make sense? Okay, that's all what I have for you guys. I do have one more chapter I'm going to go over. The other one is simpler, which is the calculation. Show you a couple of, just to review the calculation. And then I'll let you work on your project. Thank you.